The Pinpoint Microgage Laser System measures roll alignment. This video provides a brief overview and examples. First, we will go over equipment and techniques for aligning rolls parallel horizontally. Later, we will discuss roll vertical or top surface parallelism. The standard microgage laser body is made of hard anodized aluminum, built to withstand rugged work environments. A 10 arcsecond bubble level is built into the top of the laser and mounting holes are located around the body. Microgage receivers are also mostly constructed of hard anodized aluminum. This is a 2-axis wireless receiver, detecting location in both the X and Y axes with a full range of about half an inch and 0x, 0y located in the center. The receivers can attach to various mounts, including our roll mounting plate with adjustable feet and straps to accommodate a range of roll diameters. Non-abrasive feet are also available for polished rolls. The Pro Display has a color touchscreen and displays the measurements obtained by the receiver in real time. The Pro Display features onboard applications such as the bucking in program, which can be used to set the laser square to a master roll. The Pro Display can connect to 4 wired receivers and 4 wireless. The 90 line redirects a laser beam 90 degrees, which is ideal for aligning equipment square or parallel. It has a pentaprism built into the nose and can be rotated 360 to steer the beam. It also features a locking and fine adjustment knob. It is very convenient to use because no matter its orientation relative to the incoming laser beam, the reflected outgoing beam always exits within 2 arcseconds of 90 degrees. The laser in 90 line can mount to a master roll alignment plate. This combination quickly secures onto the 4-axis mount. The 4-axis mount is equipped with horizontal, vertical, pitch, and yaw adjustment knobs to dial in the laser. This combination is ideal for bucking into a master roll. To begin horizontal parallel alignment, we will first set up the laser equipment roughly square to a master roll. In this example, we designate the leftmost roll as the master. Oftentimes, a master roll is not adjustable, so it is good to use as a reference. Next, we will buck in square to the master roll to high precision. To buck in, we will measure the total distance from the 4-axis yaw adjustment pivot point to the receiver's front position on the master roll, including the beam path through the center of the 90 line nose. Then measure the distance from the receiver's front position to the rear position on the master roll. Now we can zero out the receiver at the front location. Now we can move the receiver to the back location. The prop being used freely rotates, so a counterweight is used here to balance the receiver mount. Placing a small bubble level on top of the receiver is also useful for maintaining consistent receiver orientation when taking measurements. Now observe the receiver horizontal measurement at the back location, which is -3 thou. This means the roll is angling slightly right relative to the incoming laser beam. Since the master roll is not adjustable, the angle of the laser beam will be adjusted with the 4-axis mount until it is parallel with it. Note that the vertical measurement is not needed for horizontal alignments. Rather than guessing and checking how much to adjust the laser, a quick equation provides the target value to aim at. Therefore, the yaw knob on the 4-axis mount is adjusted until 4 thou is measured. Note that our capture software can also perform this calculation automatically. Now move the detector back to the front position to check how well we bucked in. Yes, the reading at the front is also 4 thou, so we are bucked in parallel to the master roll within half a thou or better. Now we can move the detector in 90 line downstream to measure and align any other roll parallel to the master roll. Note that bucking in can be avoided if technicians are comfortable working with relative angles. The detector is moved to the front of roll number 2 and the 90 line placed on a tripod and moved accordingly. The reading is zeroed out. The detector is moved to the back of roll number 2 and the horizontal reading is observed. The reading indicates the back of the roll is angled to the right by 166 thou. This roll could be shimmed or adjusted until the front and back horizontal readings are matched, making it parallel to the master roll. Note that this is just a prop without any adjustment. The detector is moved to the front of roll number 3 and the 90 line moved accordingly. The reading is zeroed out. The detector is moved to the back of roll number 3. The reading indicates that the back of the roll is angled to the left by 156 thou. Again, this roll could be adjusted until the front and back horizontal readings are matched, making it parallel to the master roll. The detector is moved to the front of roll number 4 and the 90 line moved accordingly. The reading is zeroed out. The detector is moved to the back of roll number 4. The reading indicates the back of the roll is angled to the left by 99 thou. Again, this roll could be adjusted until parallel to the master. And so on and so forth. The laser equipment can also horizontally align rolls that are vertically offset. For this, the 90 line D with a 2-axis mount are used instead of the standard 90 line. The 90 line D has a built-in detector and the 2-axis mount allows adjustment of the 90 line D until it is perfectly centered on the incoming laser beam. Once the 90 line D is centered, the nose can be freely rotated 360 degrees and maintain a flat laser plane. There are other equipment options available which may save time. One example is using a transparent receiver at the front of the roll and a standard receiver at the back to avoid the need to move one receiver back and forth. Another option is the 4D receiver, which measures angles directly. Oftentimes, the top surface of the rolls can be leveled to gravity with a spirit level. Pinpoint offers a vertical roll adjuster which allows for leveling rolls to gravity or relative to each other. It has a built-in bubble level, fine adjustment knob, and a dial indicator. The legs are designed to accommodate rolls of various diameters. The vertical roll adjuster can be placed on a roll, then adjusted until the bubble is level. Then turn on and zero out the dial indicator. Then move it to the next roll and adjust until the bubble is level again. The dial indicator now measures how out of level the second roll is relative to the first. Here we are reading 6.5 thou over the 6-inch distance from the hinge to the knob. This information can be used to determine how much to shim or adjust the right and left side of the roll. For aligning rolls level and also in the same plane, the leveler rotation mount is used. The leveler rotation mount provides rotation of the laser 360 degrees, thereby generating a laser reference plane. It is equipped with a locking knob and a fine turn adjustment knob. Underneath, there are 3 fine adjustment knobs for adjusting its level. The leveler rotation mount can be attached to a tripod, and a dual receiver setup is convenient for leveling rolls to gravity. First, level out the laser by referencing the built-in bubble level. Then aim at the receivers and adjust the rolls until both sides have the same vertical readings. On the display, the signal strength is used to indicate which receiver is active. Move the receivers to the next roll and adjust the roll accordingly. Repeat on the next roll, and so on and so forth. When the rolls cannot be leveled to gravity but must be leveled to each other and also in the same plane, the laser can be bucked into 3 reference locations on the rollers. A 3 receiver setup, 1 transparent and 2 standard, is convenient for this. Adjust the pitch knobs until all 3 zero-matched receivers are reading the same vertical measurement. Then 1 receiver can be moved from location to location and the roll adjusted accordingly. Thank you for watching.